Assalamu alaikum. My name is Muhammad Usama, and today I will be showing you how does the Bcd to Excess 3 converter basically works. So for this I have made some truth tables over here. So before going to the truth table, I will be explaining that what is a BCD and what is basically Excess 3, what are the inputs and what basically are the outputs. So BCD is represented by 4 bits, thus there are 4 inputs in the BCD, and Excess 3 is has also 4 bits, so there are 4 outputs in the Excess 3. The inputs in this truth tables are represented by A, B, C and D, and the outputs are basically W, X, Y and Z. I have made the truth table which you can see over here. So this truth table shows that when the A, B, C and D are at 0, the output will be 0, double 0 and double 1, and when A 0, B 0, C 0 and D is 1, the output will be 0, 1 and double 0, and simultaneously this whole truth table works. So by using this truth table I have made some truth tables of W, X, Y and Z, which are basically updated truth tables. So by the help of this truth table I have made these truth tables. Updated truth table of W represents that when A, B, C are at 0 position, the W will be the output will be a 0, and for this when A is 0, B is 1 and C is 0, the output will be same as the D, which means that if the output if the position at D is 1, the output will be 1, and the position at D is 0, the output will be 0. So the output will be same as the D. So this means that. So for X I have made the truth table over here. It represents that if the 3 inputs are 0, the output will be D, and the A is 0, B is 1 and C is 0, so we will be getting a complement of D. The complement of D means that the output will be, if the D is at 0 position, the output will be 1, and the D is at 1 position, the output will be 0. So this means that the output will be the opposite of the number which is at D, that and it means that the output is the complement of D, and 100 will be also a complement of D. And for Y, if all the 3 inputs are 0, the output will be the complement of D, then D complement D and D complement for Y. And you can check this over here. The output which we are getting is basically the D and the D complement, D and the D complement. So this is represented in this truth table. And for Z, the same scenario is placed. Or for Z, all the outputs will be the complement of D. It means that we will be, if the D is at 1 state, the output will be 0, and the D is at 0 state, the output will be 1. So you can see in this truth table. So for this, so for the clearance of these truth tables, I have made the simulation in the Proteus, which I am going to show you. So this is my simulation. This is my circuitry. And I'll be now I have used these 2 muxes over here, and I have implemented the circuit. So if I run this circuit for Y, first my circuit is for Y, and for Y, if A, B, C are at 0 state, the output I will be getting will be the complement of D. So Y, if A, B, C are at 0 state, the output which I am getting is a 0, which is basically the complement of D, which you can see over here in the simulation. And further, if the inputs are 0, A 0, B 0 and C is at 1, the output which I will be getting will be the same as the D. The C is 1, and let's say that and now you can see that if A is 0, B is 0 and C is 1, the output is 1, which is basically same as D. And then we have a W circuit. So in this you can see that the truth table is made, and if all these things are at 0 state, the output is 0. So you can see that if these are at 0 state, the output is at 0 state. So you can see over here. And if I use a 0 1 1, though I will be getting a 1. So 0 1 and 1, then I am getting a 1, and then I have the circuit for x. So you can check that if I open the truth table for x, then if shows that if all the zeros, if all the inputs are at 0 state, the output is same as d. So you can check that I have implemented 0 0 0, then output is same as the d. So if I have 0 1 0, a 0, b is at 1, c is at 0, then I will be getting a complement of d, a 0, b 1, and c0, then I am getting a complement of d, which you can see, and then at last I have a d, I have a z, sorry. So this z basically represents that how does the truth table verifies for this. And you can see that all for all type of inputs I have the basically the complement of d. So if I implement 3 zeros at the input, so the output will be the complement of d. So you can verify that thing from here. And if b is at one state, c is at one state, a is at one state, then this is the different scenario which is not in this truth table. So I can see that 1 0 0 for 1 0 0, 1 0 and 0, the output is the complement of d. So this is how this circuitry basically works. You can pause the video and check out how does basically this truth table and the circuit works. So thank you so much for watching my video. Jazakallah. Allah Hafiz.